All right. So a solution to a system.
The talking needs to stop and phones need to be away right now.
Phones should all be away. So a solution is an ordered pair that makes all the inequalities true. Now we're only going to do two, so when I say all, I mean two. Could there be more than two, Esmeralda, do you think? You have more than two? You could, but we're not going to do that. Okay? And a point in the overlapping region is another way to think of our solution here. So honestly, this is really good practice on one of the main skills from all of Algebra 1, and that is graphing a line. I mean, when we leave Algebra 1, guys, especially those of you going into geometry, you're going to need to know how to graph a line. Okay? So this is really good practice for that. All right. Are you ready to graph let's graph the first inequality here. Okay? So what is the y-intercept for this first inequality? Can you tell me where to start on the y-axis? -4. So put a dot at -4. Now, from -4, right here at -4, I'll make it bigger here. You guys all see that? So from -4, where do I go according to the slope? Yes, think of this as 2 over 1. This is my slope. This is my y-intercept. And so I go up 1, 2, and over 1, and up 1, 2, and over 1. Up 2 over 1. Up 2 over 1. I could also go down 2 left 1. Now, before I connect those dots, don't connect the dots yet. We have to decide if this is a solid line or a dashed line. This goes back. That was quick. How do you know it's dashed?
Because I
Just know these things. It does not have a line underneath it on the inequality symbol like the next one does, right? So this is dashed. Now, here's what I want you to do. Listen very carefully to my instructions, please. Guys, if you have a pencil, you could probably shade real lightly, or just wait and watch to see what my final solution is. What we're going to be doing is shading two different regions and then seeing where they intersect. Okay, so your final answer is going to be just a particular region. But if I were to shade this one, where would greater than be in this? Up and to the left. Yeah, so I would shade this way. So just wait on your shading, unless you happen to have, if you want to, let's just wait. Just wait on your shading. So it would be up here. Okay, don't shade yet. Okay, I would shade to the up and to the left. I don't know if everybody heard me on that. Don't shade yet. Don't shade yet. Just wait. Just wait. Just wait. You could, if you'd like to, if you have a pencil, this won't work with a pen, but maybe shade real lightly would be okay. Might work just to know that it's going up that way. Okay. Then, my other one here, let's graph my other one. It's y is less than or equal to -3/4 x plus 4. So I start where? 4. Put a dot at 4. So put a dot at 4. And then I'm going to go down 3. And then which way? Well, if I go down 3 and left 4, I'm applying a negative here and a negative here, which would actually be equivalent to a positive. I got to go right 4. So that minus, we're applying it to the down 3. And then over 1, 2, 3, 4. And then this one we said it's, what kind of line? Solid. So I have this line. And then if I were to shade this one, from this solid line, would I go down and to the left or up and to the right? Right, down and to the left. So my shading would look like this. Now, what's happening here is these two crisscrossing lines have broken this into 1, 2, 3, 4 regions. Can you see the 4 regions in all that mess? This is why I asked you to wait. Okay, on your paper, hopefully you can see 4 regions, distinct regions. You see that? You gotta wait. So let me get the. No, but there's still 4 regions. So we have 4 distinct regions that these two crisscrossing lines have created. And only one of these regions is what you're going to call the solution to this. And it's the region where the shading has intersected. Yes, so I was going to ask that next. What region is the region where the shading has crisscrossed? It's in region 4. So call it region 4. And here's what I'm going to do. I'm going to go ahead and kind of color this in really solid here. Over here. I wonder if my thick pen would work today. It wasn't working the other day. Not only am I going to really color that in, but I'm going to go back and I'm going to erase these other lines. So you don't have to. What you could do is just make it really dark or really light, but you need to make it clear. What most students, what we typically do, and oftentimes if it's a multiple choice question on a test, they will just only darken the region that is the solution set. It gets confusing when you see other regions, but if you do it real light and then darken it, do like what I did there, like what you're doing right now would work, and then you could leave the other stuff if you want. We'll just assume that the really dark region, but this is kind of what we're looking for. See what Tony did here, see how clean that looks? Or if you flip it over to the back side, that's the type of thing they'll do in this, on a multiple choice question or something, is they'll just shade only the region that is true for both, okay? So could somebody out there tell me a point in this region 4? What is one point that works for both of these inequalities? Aaron, could you tell me one point that is in this red goop over here? No? Well, here's the origin right here. I know I covered it up. Is the origin in the red goop? Yeah. So what's one point in the red goop over here of the solution? Okay. Well, what's the coordinate of the origin? 0, 0, right? So 0, 0 works. Is that the only thing that's going to work?
No.
No. How many points are there in this region? A whole lot. An infinite number, right? So if 0, 0 works, what that means is I should be able to plug in 0 here for x and for y and get a true statement. So if I plug in 0 for y and 0 for x, I get 0 is greater than negative 4. Is that true? Is 0 bigger than negative 4?
Yeah.
Yeah. Check. What if I put 0 in the second inequality? Okay, we'll just plug in 0 there. So we plug in 0 for x, 0 for y in the second inequality, and then we check to see if it's true, right? Is 0 less than or equal to 4? That whole term drops out. Is 0 less than or equal to 4? Yeah. So that's a way to check to see if you've done it correctly. And we're going to ask you to do a checkpoint. Okay, guys? We're going to ask you to check one point. So you say, well, I don't know what point to pick to check. I say, well, there's an infinite number. Pick one. Okay, but it's got to be in one of those regions, right? So you're going to pick one and check it. And if the origin works, here's my advice to you. If the region that you shaded includes the origin, that's about the easiest one to plug in the check, 0, 0. Okay? That's a good one to check. If it doesn't, you'll have to pick a different point. But we're going to ask you to pick a point in the region and show that it works in both inequalities, makes both of them true. Okay, on the scope. So let's go through the steps. We graph each line, decide if it's solid or dashed, shade each one individually, right? Like you did 2 days ago. And then decide which region is the overlapping of the two shadings. Okay. Does that make sense, at least in theory? Understand what we're doing? The hard part is doing the algebra on something like this. So here's problem 1. Y-intercept. What's my y-intercept on the first one? And we got to be very specific. Yes, -3. And what's the slope? Yeah, up 2 over 1 again. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. All right. You could also go down to left 1. And it's messed up. So, go ahead and graph that.
Very good.
All right. So up 2 over 1. And then, is it a solid line or a dashed line? Dashed line. So draw on your dashed line, please. That's not going to work for me. Okay, go ahead and draw on your dashed line. You have to give me a minute here. See if I can get this thing under control. This board is all whacked out again. Alright, so let's see if it works now. There we go. So dashed line, which way would I shade if I were just shading this one? Would I shade up and to the left or down and to the right? This says y is less than, so down and to the right, I would shade down here. Okay, please wait on your shading. Okay, don't shade yet. Just look at what I have up here. Picture in your mind we're down and to the right. And then this one, here's where the difficulties come in. Before I can graph this, what do I have to do? Yeah, make it in y equals mx plus b form, right? So subtract 2x. So subtract 2x from each side, please. Some of you guys see are still graphing the first one. So the first one, we had a y-intercept of -3, a slope of up 2, right 1. We're supposed to be graphing that while I was getting the board back in. Instead you were up 2 over 1, up 2 over 1, and then a dashed line, and then we shade down and to the right for the first one. The second one here, we've got to subtract 2x over to make it look like the first one before we can graph it. Okay, and you're going to have to do that on these first 2 classwork problems, and you're going to have to do that on the skill test. Okay, you're going to have to solve at least one of them for y. So the y-intercept here, where do I start for this one? 2, and then from there I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, and solid or dashed line for the second one. Dashed again. It is dashed. And this says right here y is greater than this line. So would I shade down and to the left or up and to the right? Up and to the right of this line. So I have 1, 2, 3, 4 distinct regions that I have created here with my crisscrossing lines. And actually 3 out of the 4 regions have some kind of shading in them, right? 3 out of the 4 have some kind of shade. I'm sorry. I should probably be consistent, huh? It's okay. But 4 regions here. Which region is the one that is the solution set here? It is 3. So now you can go ahead and shade just region 3. Okay, that was fun. Did you get that shaded? Could you name one point in the solution set for this system of linear inequalities? What's one point that works here? 3, 1. Let's see. 1, 2, 3, 1. I would agree. 3, 1 is in the goop. As a matter of fact, if I plug in 1 for y and 3 for x, I get 1 is less than 3, and that is true. That is true. And if I plug in 1 for y and 3 for x in the other inequality, I get 1 is greater than -6 plus 2 is -4. And that is also true. 1 is bigger than -4, and 1 is less than 3. So we've done it correctly. We could erase all this other stuff here. I can. And we have our solution set. Unfortunately, the origin didn't work for this one, so we had to plug in something else. But somebody mentioned some other points. What's another point that worked? Somebody said, what's that? 0, 0, 2. It's on the line, but not in the shaded group. Yeah. What's another point that works? What's that? 4, 3. Let's see. 1, 2, 3, 4. 1, 2, 3. Yep. You got to just be careful you don't go up too high, or we'll be right out of there again. But yeah, 4, 3 looks like it works. 5, 2 would definitely work. Yeah. So you get the idea, right? No. Who put you in the front row? All right. Now, as we oftentimes do in math, and I'm going to ask you to do it on the classwork, not on the skill test, but in the classwork, is, Aaron, we work backwards. So in this case, in this example, I'm giving you the shaded region in the 2 lines, and you have to come up with the original inequality. Okay, I think we can do that. Yeah. Okay. Let's see if we can do it. If I can tell on here which is the actual shaded region. I believe this is supposed to be the darkened region. Can you tell on yours? Oh, is it that one over there? Okay. Okay, let me redraw this then. So we want to get, it looks like on yours, this region right here. My picture is not very good. I think one portion is supposed to be darker than another. All right, so this dashed line, remember, we're trying to get it to fit y equals mx plus b form, except instead of an equal sign, we want a less than or a greater than sign. So this dashed line right here, what is that point right there? That is my b. I think that's the easiest thing to find first. So what is that point right there? It's 1, 2, 3, 4, 5. So we can put 5 in for b, and it's a plus 5. I've gone up 5, right? We'll kind of work backwards here. So we know what b is. B is 5. X, I'm going to leave x alone. What else do I need to find here? We're kind of working from our right to the left. So slope, we need slope. So can we figure out, so this is my b. Can we figure out the slope here, m? It's a different color. From this point, I go down 1 and over 1, 2. Down 1, over 2. Down 1, over 2. So what does m equal if I'm going down 1? What's the top part of m? If I'm going down 1. Down 1. Negative. Negative what? 1. And if I'm going right 2. Positive or negative? Okay, so m is negative 1 over 2. So I can go ahead and put negative 1 over 2 in for my m. Now, I'm not going to have an equal sign there. What does the dashed line mean here? What kind of symbol do I have? I guess we could ask this all at once. Is this a less than or a greater than? Or is it a less than or equal to or a greater than or equal to? Okay, it could be a greater, it's dashed, but greater would be up and to the right. So it's a less than. Now why is it not a less than or equal to? It's a dashed line, and so it's a strict less than. So it should say y is less than that. So there's my first inequality. Y is less than that. Okay, let's see if we can work backwards on this guy right here. Can you tell me what b is on this solid blue line? Can you tell? Looks like it's -1, so we're going to put -1 in for b. I know the x is going to be in there, right? The x is always in the inequality. So put in the b is -1, the x is there. What's my slope on this guy? So this is b. My slope is, it looks like up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's 1 over 1 or just 1. And then this time, it's a solid line, and it's greater than or equal to. So it's greater than or equal to 1x minus 1. And so we've worked backwards and figured out what the two inequalities were that gave us this picture. I'm going to ask you to do that as well. Okay. So problem 1 is like your first two examples. This one is like the last one on there, and then in between I ask you to plug in some points and tell me if there's solutions, things like that. So how do we check to see if something's a solution? Plug it in, yeah, plug it in, and see if it works in just one of them, both of them. So that's it. Let me go ahead and test out the classwork. And then when I'm confident you're ready, I'll give you